Okay, so every morning I spend some time doing some learning, and I was wondering what to make next, and I thought it'd be fun to make an operating system. I've never done that before and have no idea how to. I know a little bit of Rust, um, not much, and I figured I'd give it a whirl and just learn as I go and make these videos of it to keep me motivated. So probably do this about an hour or two every morning, and I'll just start by making a new. Um, got my projects in here. Um, let's see. How about just call it my OS or OS for now. I'm gonna switch over to active projects, OS, open, perfect, and I'll get in it and make a new repo. Give it a good name later. I'll make it open source for you guys. And copy that. That thing. Cool. And now we need to learn how to even begin to start thinking about this kind of thing. I know I'm probably going to want to use QEMU or QEMU. I don't know how to say it. I have that somewhere. Oh. I have that somewhere. Huh. Okay. Well, yeah, I don't even know what that really does. So let's ask this guy to help us out. I'm wanting to make an operating system. How can I get to a hello world OS? Use grub or UEFI. Write a simple kernel that sets up minimal CPU state, initializes video output, and prints hello world. Look, it gave me Rust. It's because it knows I like Rust. Okay, that's very well, but you're jumping too far ahead. Can you give me the very first step? Yeah, I have my assistant set to give me very terse responses, which is usually good, but sometimes it's a little bit too much. Okay, how? Well, actually, no, wait. I feel like I want to build this for ARM, maybe. Like, which is, I'm on an M2 Mac. So wouldn't it be easier to make an ARM OS, ARM64, yeah. QEMU for ARM, start a simple bootloader. Docker for your build environment. I don't really want to use Docker if that's okay. But let's start with QEMU. Yeah. Oh, do I have the most? We'll try that anyway. Install. What is the cross compiler for? Lets you build code for ARM architecture that runs directly on hardware without an underlying OS. It creates binaries with no dependency on macOS libraries. Runtime essential for OS development, where you're building the runtime environment. That makes sense. Okay. How do I install it? Brew install ARM none EABI GCC. Okay. it's working. There we go. Do I have that thing kicking around now? Yeah, look at that. Okay, and okay, I did that. Now what? Oh, .c. I kind of wanted to use Rust. Wait, that's not how you do it. There we go. Okay, create a minimal kernel. Let's just try this. Just give it a whirl. I'll make a. I mean, do I need to like? Should I like? Do that? Okay. All right, let's try that. So let's do like cargo init. And then go into cargo.toml and give it all this stuff. OS project is probably good for now. 2021's good. Dependencies. I do remember seeing these before, but I don't remember what they do. We'll probably find out shortly. And then make that minimal kernel, which is in here. So I'm gonna say like, oh, I do know what this does. This says like no stud. That makes it so we have no access to the standard library, which is why now we get errors with print line. And then no main. Oh, that's weird. So I don't need that anymore either. And I'm gonna use core panic info. Not sure what that is. A struct providing information about a panic. It's passed to the panic handler defined by panic handler. Okay. Oh, here we go. Panic handler. This is a panic handler. Function panic. So I'm making my own panic. Info. Okay, yeah. So it takes this panic info. Panic info. Returns never. And it just is an infinite loop, I guess. Not sure what's going on here, but we'll just ignore that for now. No mangle. No mangle. I think I sort of know what that means. Pub extern C fun start turns never. I think that's what never is, right? Yeah, right. Okay. I don't use that very much in Rust, I feel like. Let UART equal UOX09. Oh dear, no one use that. 1, 2. Okay, let's copy pasta. That as what? U8. What does star mut U8 mean? I'll ask the chatty over there in a second. Okay, let hello is it's hello world. Yeah, okay, perfect. And then for byte in hello, unsafe, that's not good. We say UART equals byte. Still not sure what this UART thing is. But yeah, and then we loop infinitely. Keep it running, I guess. I'm gonna restart my LSP. Okay, so it's a real issue, seems like. Well, maybe it's not. I restarted LSP in it, now it's happy. Oh, never mind, I just saved it, now it's not. Okay, well, we'll just see what happens. So it says build and run. Wait, which one of these? Wait, no, this. Wait, build and run. Cargo rest auto. Oh yeah, cargo. Okay. Cargo build dash target arch 64 unknown none. It's kind of what I was anticipating. We got can't find crate for core. That target may not be installed. Consider downloading the target. Rust up target. Oh, look, I've done this before. Okay. Apple iOS. Oh, these are cool. Apple. So I'm looking for like Arch. This one is the one I want, right? Okay. So what was it suggesting that I prior to this is suggesting this. Let's try that. And can we try this build again? Should we get a different error? Well, that is not what I was expecting. It actually kind of worked. Really quick, can I make it always build for that target? Is there some config file? Because I kind of remember this being the case. Yeah, sounds right. I go here, I make a .cargo/config.toml, and then I can say like build target equals AA arch 64 unknown none, and then I'm gonna say target.arch. Whoa. Wait, what are those like? I'll save that for now. So now if I run cargo build, it just works. Can't find crate for test. Let's just LSP. It's actually compiling. This has the target here. I think it's working. Where's my cursor? I lost my cursor. There we go. Okay. Okay, it is building now. What do I do now to actually see it? C/run it. Okay, I have no idea what that means. Cargo rust C --C. When I run this, oh wait, is it this whole command? All in one shot? That's what I thought. Well, luckily, I think I can say like terminal, and then it'll be able to look at this. Yes, perfect. Okay. Got that. You need to create the linker thing first. Oh. All right. Well, it's not too bad. In your project root, what do I name the file? Didn't it say up here? Linker.ld. Okay. All right. Linker.ld. And it's gonna be this, pretty much, right? Shouldn't there be like a... let's just get this break. Okay. Now I got a linker.ld. And now, try this again. Oh, that worked. Who would have thought? Okay. And then I do the QEMU dance. So now we say like QEMU system arch AA arch 64 dash machine virtual I'm assuming dash CPU. Wait, how much of this is on one line? I can't really tell. I think it's all supposed to be one command. Because if I brought this all the way over here, yeah, it's all one line. Okay. Dash CPU Cortex A53 dash kernel target slash AA arch 64 unknown. Oops. Wait. Oh, unknown none. Yeah. Debug OS project. And dash no graphic, whatever that means. Did that do something? Hello? I can't control C it. It's kind of stuck. I close the window. Okay, when I try that QEMU command, it just hangs, freezes. Oh, it's expected. Oh. Perfect. I wonder if I did the same thing without the no graphic. Look at this. How do I get out of here? I'm stuck. My mouse is trapped. Oh look, press Control Option G. Control Option G. Wow, that's awkward. Look, I can't even like type in here. Hi. Okay, so something's happening. Doesn't look like my operating system, but alright, so we'll go into, can I stop this now? There we go. Okay, perfect. I'm gonna go into, first I'm gonna make a just file. Just file. If you don't know what just is, you should. Except I always forget. It's like, oops, not emojis. Snippets. Just file. Boilerplate. Okay. Just QEMU will be this command, right? This thing right here, which is kind of lengthy. Copy that and put it there. Alright, and then close those. So now if I go here and I say just, it'll open up a fuzzy finder and I can hit QEMU and it'll do that. And I can cut it out like this. Okay. Perfect. So now it says do this, so maybe I'll just do what it tells me so it doesn't get confused. Core panic info, I use another one. Use core PTR. I don't know what that is. Manually manage memory through raw pointers. That sounds fantastic. Ooh, that's a lot of information. Okay. Panic handler stayed the same. No mangle extern C. Let UART. Oh wait, this is different. This is fundamentally different. So wait, rewrite all this. Let UART base star mut u8. I still don't understand what that star mut u8 is. Equals 0x9000000 as star mut u8. Alright, and then for my next trick, let hello equal be hello world. Bang, new line. And then for byte in hello, unsafe, ptr : write volatile. That's scary. UART base, and then byte. and then loop it forever and ever and ever. Look, oh, it's a const. Now you'll be happy. Let's try the same thing. Cargo build, and then QEMU or just QEMU. Okay, this nice. I'm not seeing my hello world. When I switched the code out for what you just gave me and removed the no graphic flag, QEMU fired up, but I'm not seeing hello world. Let's see what you have to say about that. Oh, add the no graphic back. The issue is likely the UART address. Let's try this fixed code. Listen, if you're just gonna be giving me fixed code over and over again, so go to the just file. Add the no graphic back. Dash no graphic. And just QEMU. Look, but then it doesn't even. When I add the no graphic thing, it doesn't even open up a QEMU window. All output to the terminal you're running it from. Oh, that makes sense. If you're not seeing hello world in your terminal, well, okay, let's try a couple of these. So that's not working. Let's copy all this. Oops, 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 oops. Oh, that's too fast. That's too fast. That's too fast. This. Down to that. Was that the right thing? Yes. Okay. Now go back over to my main. Put that in there. Our cargo build. And this was the command, right? Okay, let's copy this. Shucks. It's still just hanging. Yeah, I'm not seeing it. It's incorrect. Let's simplify with a QEMU specific approach. Sounds good to me. Is it simpler? I don't know. Oops, I can't. Cargo build. Uh-oh. Immediate must be an integer. When I run cargo build on file. This guy, I get this. Fix the so you could be in the valid range. That's so helpful. Oh dear. Just take that much. Now it works. And we just QEMU. All right, this guy's not being very helpful, in case you haven't noticed. I mean, he's trying, but it's not really helping me very much. So I'm going to try a new approach. There is somewhere, there's that like fill guy. That writes an operating system in Rust. So I just want to take like the very beginning of this, and then I'll go on my own after that. But just to get me started here, I think this will be good. I have done part of this before, but I never really tried to keep going on my own. So I'm going to yes. Okay, that kept the hidden files, but I can get rid of that. So I should just have the git folder. Perfect. Okay. Now, here's what I want. I want this. Can we bring this over here? And then we can actually do some oops. I don't want this fill guy. Thank you. I wanted this, like this. Perfect, okay. Freestanding Rust binary. Excuse me. Cargo, new blog. Oh wait, mine is not called blog OS. Oh wait, I already have this OS folder. This is bad. Okay, so let's go up here. And we'll make a new one. Cargo, new. What's a good name for an operating system? What are some operating systems out there? Linux, Mac OS, Windows, Android, iOS, Serenity. No. We'll just call it my OS for now. My OS. Or I'll just call it foo OS for now. OS. Okay, -- bin, and then -- edition 20. Wait. No. I want the latest and greatest. Alright, and then I want to open up here foo OS. This is the new operating system. And then do this dance again. Okay. Okay, and then we need to go over into here and not add the standard library again. No stud. Now we get errors on this print line, just like it says we will here. I can pull this up a little bit if you want. Okay, no stud, and then so remove the print line. Perfect. And if I cargo build, it says panic handler function required. Panic implementation. All right, this is easy enough. So I'll make use the same thing as the other thing, right? So core panic info, and I'll make a panic handler down here. Panic handler function panic info. And panic info, returning never, and looping forever. By the way, if any of you are interested in this thing I'm using, it's super good. This guy Phil Opperman or something, he's working. This is like the 2nd edition. He's working on a 3rd edition. It's been a little while. I don't know how that's going, but I'm just gonna use this to hopefully just use this to get started, and then try to go off on my own. Alright, the personality. I feel like that's kind of my personality. Alright, disabling unwinding. There are other use cases as well, which unwinding is which provides an option to abort on panic instead of unwinding. Oh, this is perfect. disables the generation of unwinding simple information and thus considerably reduces binary size. There are multiple places where we can disable unwinding. The easiest way is to add the following lines to cargo.toml. Let's do that. Probably down here, no? Profile.dev panic equals abort and profile.release panic equals abort. Perfect. And then now if we say cargo build, we haven't done the no main thing because this is a little bit different. Maybe it's because he's using REST 2018. We'll just keep chugging along. Overwrite the entry point. We do that by saying no main. No main. Wait, notice that we removed the main function. Oh yeah, sorry. Now we're getting like linker errors, which are bad things. By using the no mangle attribute, we disable name mangling. Okay. Oops. Oops. Oh dear. Now we've got that. This guy's gonna be so happy now. No, he's not. Okay. No mangle. So that Rust actually outputs a function with the name start instead of like this. Okay. Linker errors. That's what we have. Don't include the C runtime. Okay. Building for bare metal target. A default Rust tries to build an executable that is able to run in your current system environment. For example, if you're using x86, to describe different environments, Rust uses a string called a target triple. See the target triple? Ooh. So now at this point, because look, if I were to go Rust C -- verbose, check it out, I'm on Apple Darwin. So I think he's gonna do x86. So we'll go with him. I guess we're switching to x86. Such a bare metal environment is the Thumby V70M None Yabif target triple. Describes an embedded ARM system. Wait, ARM? I thought we were doing x86. Details are not important. All that matters is that target triple has no underlying operating system, which is indicated by the none. Add it to rust up. Okay. Rust up. Add or how does it go? Target. Add. Thumb. BV. Oh wait, is he just doing this as an example? I think he is. Okay. This is what we have. For example, we could do that. Yeah, see, that works. Alright, so now can we get the minimal kernel? Because this is where I really want to get to. Boot process. Oh yeah, so this is where it's kind of complicated. He explains BIOS and multi-boot standard and UEFI. This is something they want to support in the next edition of this blog, I think. For now, I'll just do whatever he does, which I think is whatever the alternative is, BIOS. And yeah, just oh yeah, this is what you do. You go like Rust toolchain nightly. Okay. target specification. Target triple. Okay. All right, we're getting there. We're getting there. All right, let's try this. Except for, oops, mine isn't blog OS, mine's foo OS for now. And then I need to like copy all this. Blog, okay, perfect. And note that we changed the OS in the LLVM target and the OS field to none because we will run on bare metal. Perfect. We add the following build related entries, like add those down here or something. Is that what you're saying? Linker flavor. Instead of using the platform's default linker, which might not support Linux targets, we use the cross-platform LLD linker that is shipped with Rust for linking our kernel. Panic strategy abort, okay. Oops. And wait. This setting specifies that the target doesn't support stack unwinding on Panic, so instead the program should abort directly. This is the same effect as the Panic equals abort option or cargo.toml, so we can remove it from there. Okay. I'll get rid of the cargo one just to make it simpler. Alright, and then disable red zone. Okay. Sounds good to me. And then features, add some features. Features are good. MMX and SSC features determine support for single instruction. Oh, SIMD. I like SIMD. Yeah. Yeah. SIMD. Alright. And then do that. So at the end it looks like this. Let me just double check if mine does look like that. Yeah, pretty much. Okay. Then building our kernel, compiling for our new target, we'll use Linux conventions since the ld.lld linker flavor instructs LLVM to compile with the flavor GNU flag. This means that we need an entry point named start as described in the previous post. Don't I already have basically all that? In case I don't, I guess I'll just copy pasta. Okay. I don't know why I'm getting this error. And then we'll now build the kernel for our new target by passing the name of the JSON file as target. We will say cargo build -- target x86 64 this. Uh-oh. Wait, okay, this is not good. What if I get rid of this? Ah, that's more like it. Can't find core. That's what this guy's saying too, right? Error 0463. Perfect. Fails. Library tells us that the Rust compiler no longer finds the core library. Basic Rust types such as result and option and iterators, and is implicitly linked to the no standard, to all no standard crates. The problem is that the core library is distributed together with the Rust compiler as a pre-compiled library, so it is only valid for supported host triples. Example, x84 unknown Linux GNU, but not for our custom target. We want to compile code for other targets. We need to compile core for these targets first. Okay. That's where the build stud feature of Cargo comes in. It allows to recompile core and other standard library crates on demand instead of using the precompiled versions shipped with Rust installation. This feature was very new and still not finished. I think this blog is a little bit old, so I think I'll be good. So it is marked as unstable and only available on nightly Rust compilers. To use the feature, we need to create a local cargo configuration file at cargo config. Okay, that's what I had earlier, right? Cargo/config.toml and say unstable build stud equals core and compiler built-ins, not built-ins but built-ins. Okay, this tells Cargo that we should recompile the core and compile the built-ins libraries. The latter is required because it is a dependency of core. Okay, in order to recompile these libraries, Cargo needs access to the Rust source code, which it can install with Rust component add Rust source rust.component add Rust source. Okay, it's up to date. After setting the unstable, wait, what is this? Oh, okay. So now we can cargo build again. That's the exact same error. Did I skip something? Can't find crate for core. That's the same error he was having before, but he fixed it. All right, well, maybe with this error, I will be done for this morning and hopefully pick it back up tomorrow morning. I gotta go practice banjo or something. So I'm hoping to do this most mornings. Just record this and then maybe at the end of every month, if I keep doing this for a while, make like an overview of what I accomplished in that month, so that if anybody wants to like do a quick recap of like what I've been doing, then they can just watch the month ones and not every single long day one. But that's the idea. We'll see what happens.